Everyone, I'm glad to be here to present work from our group. Binh Nguyen from Victoria University of Wellington. First, I want to introduce about our research group. It consists of 5 PhD students and myself. We are doing data science, machine learning, and deep learning, and application in various domains, including health informatics, bioinformatics, and drug discovery. The work I'm presenting today is a model to predict compounds that can be used for treatment of multi-target cancer. So we know that cancer is a very dangerous disease that causes millions of deaths every year. And the problem is to screen to see if a drug can be used for treatment of cancer or not. It's a long process and take a lot of money and time. But luckily, we have the U.S. National Cancer Institute. They screen multiple drugs every year, and they update the data annually. This is a very reliable data set so that we can use to develop our model. And another motivation is predicting multi-target cancer compounds now become a hot research trend because of various reasons, including drug resistance. And there are some framework they already developed for predicting multi-target compound for cancer. However, they are now all outdated or we cannot access the server. So that's why we try to develop a model using multitask learning with graph convolutional neural networks to predict multi-target cancer compounds. We use the NCI dataset, and we predict 9 types of cancer. So here we have a dataset after cleaning from developed from the NCI server, and we predict 9 types of cancer. Here we have some information about the dataset. As you can see, this is a heavy imbalance dataset. And using this dataset, we get 10% to create a test set, and the rest we use 85% for training a model and 50% for validations. First, we need to, because the structure of each drug is a string represented as a small string, and we need to convert it to data structure so that we can use for our model. And here we use graph neural networks, so we convert each string into 2 matrices. The first matrix carries the information, the feature about all the atoms in the drug structure. And the second matrix carries the bonding matrix to represent the bonding between different atoms in the drug. With these 2 matrices, we put them into a model. And here is the architecture of our model. We get some idea from the ResNet architecture, which is a very famous neural network architecture in computer vision. We use 2 types of shortcuts similar to ResNet. But in ResNet, each CNN block consists of 4 CNN layers. And here we use graph convolutional neural network blocks. And also we use 2 types of shortcut. One is a standard shortcut, and the other is a shortcut going through one graph convolutional neural network. And using the same shared graph architecture, we apply multi-task learning with 9 tasks corresponding to 9 branches of groups of graph convolutional neural network. And we change the whole structure at the same time using the dataset from NCI server. Here we have some information about the training process. We use PyTorch, Google Colab, train the model over 16 epochs, and use loss on the validation set to choose the model. For training each epoch, it took about 60 seconds, and for testing, it took only 4 seconds. We perform a lot of experiments to verify the effectiveness of our framework. First, we want to see the contribution of two types shortcut connections. So we implement 4 types of models. The first one using 2 types of shortcuts. The second one using only the standard shortcut. And the third one, we use only the graph convolutional shortcut. And the last one, without any shortcut. And the performance on the test shows that the model that we propose using 2 types of shortcut achieve the best performance among the 4 models. And also, comparison between multitask and single task, we also achieve higher performance with multitask learning. For comparison, we perform the comparison with 2 other models, and the performance also shows that our model better. My time is up, so thank you.